So let's go ahead and then solve the next example. The next example also talk about a sinusoidal carrier voltage of frequency. That's carrier voltage with frequency. That means the frequency of the carrier is equal to 1 megahertz. And the amplitude of the carrier, which is AC, is equal to 100 volts. And it's modulated by the sinusoidal voltage of frequency 5 kilohertz, which is FM is equal to 5 kilohertz. Producing a 50% modulation. When you see the percentage, this means that it is the modulation index, and we can say that our modulation index is 0.5 because it's out of 100. When the modulation index is 100%, it means that the modulation is 1. When it's 50%, the modulation is 0.5, and so on. Now they said we should calculate the frequency and the amplitude of the lower and the upper sidebands. So as I'm saying, the FC, which is the frequency of the carrier, is equal to 1 megahertz or 1000 kilohertz. The frequency of the message signal is also 5 kilohertz, and then the amplitude of the carrier is 100 volts. Now let's go ahead and calculate whatever we have been asked to. So if we are to calculate the frequency and the amplitude of lower and the upper sideband, this is what we are going to do. The lower sideband have a frequency of FC minus FM. And this is straightforward, which is what? 1000 kilohertz or 1 megahertz minus 5 kilohertz. And this is supposed to give us 995 kilohertz. And then the upper frequency is FC plus FM, which is equal to 1000 kilohertz plus 5 kilohertz. And this is supposed to give us 1005 kilohertz. Now let's look at the amplitude of the modulated signal. So the amplitude, based on the tutorial, our first tutorial that we did, we came up of the various components of the AM modulated signal, and we found out that S of t is equal to AC cos omega ct plus MAC over 2 cos omega c minus omega m or t plus MAC over 2 cos omega c plus omega m. I hope you are aware of this or you remember it. And therefore, based on that, our amplitude for the various sideband is this one and this one. Since the various sidebands have the same amplitude, we can see that the amplitude of the lower sideband and the upper sideband, it's equal to ACM over 2, which is equal to the modulation index is 0.5 times 100 volt, which was given in the question, divided by 2, which will result in 25 volts. So this is the answer to this particular question. You can see that this is not a difficult question at all. Let's look at these two examples. Let's quickly look at these two examples. An audio signal of 1 kilohertz is used to modulate a carrier of 500 kilohertz. That means that the FM is equal to 1 kilohertz and then FC equal to 500 kilohertz. And we have been asked to determine the band frequency and the bandwidth required. The band frequency or the sideband frequency is FC minus FM and FC plus FM. So in doing this, we have 500 kilohertz minus 1 kilohertz and also 500 kilohertz plus 1 kilohertz. So in doing this, we are going to get this one to be 499 kilohertz and this one to be 501 kilohertz. So let's look at the bandwidth. As I said, the bandwidth of AM modulated signal is BW equal to 2 FM. So whatever the message frequency is, the bandwidth multiplied by 2 of that message frequency will give you the resultant bandwidth. And therefore, our message signal, it's having a frequency of 1 kilohertz. So multiplied by 2, we are going to get 2 kilohertz for the bandwidth. So now let's look at the second one. The second one talks about the antenna current of an AM transmitter to be 8 amperes when only the carrier is sent. I think here to be full stop. But it increased to 8.93 amperes when the carrier is sinusoidally modulated. We should find the age modulation. So let's look at how we'll be able to answer this question. Take note here that when they say find the age modulation, whatever they are asking you to do is to find the modulation index. Before I proceed with this, I want to let you understand certain thing here. Power is equal to voltage times the current. This means that the power is directly proportional to the voltage, or it's also directly proportional to the current. So if I have a ratio of power 1 over power 2, it's equivalent to I1 over I2, and it's also equivalent to V1 over V2. So let's take note of this. So based on this, we are aware that we have a total power equal to the power of the carrier plus the power of the sidebands. If you have forgotten, please refer to my previous tutorial to kind of refresh on it. And it's also equal to the power of the carrier was giving us AC squared over 2R plus AC squared M squared got here M squared plus AC squared M squared over 8R. And from this, we came out for a general formula to be PC into bracket 1 plus M squared over 2, where the PC is the power of the carrier wave. So based on this, we can say that this PT is the total power the antenna received, and is equal to PC of the carrier into bracket 1 plus the modulation index over 2. And from there, we can divide both sides to get PC, and we are going to get PT over PC equal to 1 plus M squared over 2. As I said earlier on, based on the question, we have been given the transmitter, AM transmitter current to be 8 amp, and then when it is increased to this thing, or let's say the AM transmitter has a current of this one when it's only transmitted by the carrier, but when it's increased to 8.93 when the carrier is essentially modulated. So this means that the receiving end was having what? 8.93 amps, which is the current that the antenna received, right? And then the carrier part is the
this question for you as
current that
please come back
is carried by the carrier
after we are done solving the other question together.
Let's solve this particular example. The RMS value of a carrier voltage is 100 volts. That is V RMS is equal to 100 volts. And this RMS is equal to AC, let's say AC RMS. After amplitude modulation by sinusoidal voltage, the RMS value become 110V voltage, which is equal to V RMS, let's say 2, here's 1, and it's equal to AC2, here's AC1 RMS. Right? Remember that these are voltages, and as I said, the power of the transmitter, the power of the carrier is equivalent to the respective voltage, and then it's also equivalent to the respective current. And therefore, based on the value which is given, we can replace it by the voltages. So we can say that our PT over PC is equal to VT over VC equal to 1 plus M squared over 2. So this is as simple as that. So based on this, remember that this, they are all square of it. is equivalent to the square of this. Take note of it. And then the reason is that when we are using, let's say, the resistance, the power becomes P equal to V squared over 2R for the VRMS, right? So based on this, when we want to replace the voltages in place with the power, we are going to get the VT over VC all squared. The same one appears to the current. You can also say that the power is also related to the current by IT over IC and the all squared because of that formula here. So based on that, when we replace this, we are going to get 110 over 100. And remember, it's all squared to be equal to 1 plus m squared over 2. Making m squared over 2 the subject, we are going to get something like 0.21. And when you multiply by 2 and you take the square root of it, 2 times 0.21, you're supposed to get something like m to be equal to 0.21 times 2. That's the square root, which is equal to 0.648, which is approximately 64.8%. So this is basically some few things that you have to take note of. So please take your time, look for more questions and solve it, and that's the only way that you'll be able to
So this is
solve
the
any question that will be given to you or that
solve it
you will
yourself. But for the
encounter
meantime,
in the future. Thank you for watching and see you in my next video.